Welcome back to the morning show, 7:25. Time for part 2 of our Wise Guy segment. Matt Sellen is here. And Matt, you gave a little teaser last time. We got a quiz question answer for us.
I did too. So here's what we did. We got this glass vibrating. And any kind of musical instrument, anything that makes a sound is going to have a standing wave in it, something that resonates at a certain frequency. And so this is no exception. Okay, so this is where it was before.
Right.
Now I'm going to pour a little water in there.
Just add some volume to the water.
Now the water's higher up and it's lower. Okay, which is a little surprising. And you can see, if you look carefully in the water, you can see the vibrations in the water.
Oh yeah.
You can see the funny nodes. So you can sort of see what the wave looks like. You have areas where you have no vibration, or you have areas with big vibration. And that's the same like in the guitar. No vibration at the end, big vibration here. For this thing, when you have open ends, right, you have big vibration there, no vibration in the middle. Sure. And so you can look at any musical instrument and you can see either it's going to be a string or it's going to be some sort of air deal. Right. And with the air ones, you know, depending on what's at the end of it, if it's closed, different sound than if it's open. And then the length. Okay, so anyways, Doppler effect is something that I was kind of promising to talk about, and it's sort of interesting, and it's the thing that makes that sound. If you're at the racetrack where the car's coming at you, you hear a high pitch. Right. When it passes you, it's lower. The same thing you hear at a train track. And we can demonstrate that with this little tuning fork. If I just whack that, and then I go, okay. If I move it back and forth, you can hear it a little bit when it's coming towards you, or you can at least hear the pitch changing when you're doing that. And it's kind of very simple to see this. Think of these vibrating tuning fork tines. They're going back and forth like this, and they're sending off little air compressions, okay, towards you or towards anybody that's listening. Sure. The air's not really moving, it's that the compression wave is moving. And if you think of these waves as little objects, okay, and for the purposes of this next demonstration, you'll see why the pitch ought to change. So what I'm going to do is...
Got just about a minute left. So
okay, so I'm going to chuck these balls at you. If you're not moving, then the rate that you catch those balls at is the same as the rate that I throw them at.
Right.
Okay, and the rate is the frequency, which is the pitch. Now, suppose I'm throwing these at you while I'm walking towards you. Okay, now, I was throwing them at the same rate as before, but you were catching them faster. Right. That's because every time I throw the next little sound wave at you, I'm a bit closer than I was before, so the sound waves get crowded together on their way to you, and then you catch them. Sure. If the other thing happens, if I'm walking away, and I don't walk into the tree, okay, then I'm throwing them at the same rate, but now you're catching them at a lower rate than before. So really all it is that when you're moving towards the object that's listening, the sound waves that you're sending towards that object get sort of crowded together, and by the time they get to that person's ear, you hear them as a higher pitch.
Very cool.
And you get the same actual effect with light, it turns out. Stars that we look through with telescopes, or we look at with telescopes, if they're moving away from us, which most stars are, then they become lower frequency light, and so even though they were emitted at maybe blue, if they're going away from us fast enough, they look kind of red to us.
Red. Wow, very cool, Matt. All right, well, thanks for the information. You want to play guitar a little bit?
Oh, you think? You gonna sing?
No, I'm not going to sing, but you can play it while we put up your information. If folks have questions for Matt or the morning show, you can send them to themorningshow@wci.com or wiseguy.net. Go ahead, play for a few minutes.